Okay, today we'll be talking about long division, and I have a helper. So first, let's just remind ourselves what the steps in the algorithm are, and then we'll talk about why they make sense. And today we'll be using money to explain that, but then I'll talk about why that's not maybe the best explanation. Okay, so I'm going to divide 532 by 3. So we're going to proceed digit by digit. Okay, so 3 goes into 5 just once. With a remainder of 2. Bring down the 3. 3 goes into 23. Well, let's see. 3 times 7 is 21. That would leave a remainder of 2. So 3 times 7 is 21. Remainder of 2. Bring down the 2. And again, 3 times 7 is 21. So I have a remainder of 1. So the way that I'm going to write the result of this computation is 532 equals 177 times 3 plus the remainder of 1. Okay? I am not going to write, well, we'll talk about that another time. So I'm going to explain this using some Monopoly money. And this is a way that you could start explaining to kids. It's not a terribly complete explanation. So it shouldn't be the only explanation that kids ever hear, but it's decent to begin. So I'm going to take, I have 500, I need to scoot up here. I have some Monopoly money here. I have $532. So I'm going to start by dividing these into 3 piles, and because I'm outside, I'm going to use these egg cups as paperweights. Okay, so I'm going to start with my $100 bills. I have 5 of them. So I'm going to divvy these up. I can put 1 in each of 3 piles, right, which corresponds to this 1 here. Oops. There. Corresponds to this 1. But then I have 2 left over. Okay, so banker, can I please have, for these 2 $100 bills, can I please have 20 $10 bills? Thank you. Okay, so now I have more than 3 bills, so I can start divvying them up again. So I have 23. Once I add these tens from my pile of money, I will now have 23. So I had 3 $10 bills. I now have 23 $10 bills, so I can divvy these up. 1, 2, 3, 4, 5, 6, 7. Oh, and now I have fewer than 3, so I have to stop. Okay, so the 7 $10 bills in each pile, that corresponds to this 7 right here. And the 2 10s that I have remaining, that corresponds to this 2 right here. Okay, so banker, can I please have 20 $1 bills for these two tens. Okay, so I take the 20 $1 bills, which corresponds to this 2 right here, and then I take the $2 that I already had, put them together for 22 $1 bills, and now I start divvying up again. 1, 2, 3, 4, 5, 6, 7, and now I have fewer than 3, so this is my remainder. Okay? So each pile has 1 $100 bill, 7 $10 bills, and 7 $1 bills. And I have a 1 left over. Now what's the disadvantage of this explanation? Well, for one thing, students could say, well, why don't you use $20 bills? It's like, well, because that doesn't correspond to a digit. That would be confusing. Also, here you go, banker. There's also this. Let's say this page got torn. All right. Okay. So I see this 7 here and this 3, but I don't know if I'm really dividing 3 by 53 or if there are supposed to be digits over here. But the truth is, it doesn't matter, right? Because I proceed digit by digit. 3 goes into 5 once with a remainder of 2. The steps are exactly the same, whether this 5 means 50, whether it means 500 like it did in our problem, whether it means 5,000. The steps are the same. So if this had been a 5,300 something, I would have needed $5,000 bills rather than $500 bills. So the explanation with money is slightly misleading. The actual algorithm is actually simpler. So in our next video, I will be providing a more complete explanation that does not refer to money. Thank you, banker, for your help. Come on.